All right, Earth Science Chapter 1 review for Earth's interior. Go ahead and look through all of the information on here so that you're prepared for the test coming up. All right, the first thing to know is that our Earth is made up of layers. Make sure that you know the order in which those layers happen and where they're found. So you should have an inner core, outer core, mantle, and a crust. Remember, you have a song to remember this: inner core, outer core, mantle, and crust. Within the crust, make sure that you know that there are two different types of crust. So there is the oceanic crust, as well as the continental crust. Know the differences between those. Know that they're made up of different materials and they come in different sizes, right? Oceanic is 0 to 5 kilometers. Oceanic or continental is 0 to 40 kilometers, and sometimes as much as 80 kilometers if you're going to the highest peaks of mountains. In the mantle, there are three different parts. There is the mesosphere, the asthenosphere, and the lithosphere. Now this top layer here, the lithosphere, is a combination of crust and upper mantle. And it includes our tectonic plates. Plate tectonics are controlled by convection. Remember convection. Convection is when we have hot material coming from the bottom, moving up, cold material coming from the top, moving down based on density. So those plate tectonics are controlled actually through the asthenosphere, because that is where convection occurs. Now the plates reside within the lithosphere, but the actual movement of the plates is controlled through the asthenosphere. Okay, that's enough about the center of the Earth. Let's talk about plate tectonics and what happens at the different types of boundaries. So we've got the three different types of boundaries. We have divergent, convergent, and transform. The first of these I want to talk about is a divergent. So in a divergent boundary, you're going to get the plates moving away from each other. Now at a divergent boundary, because these are moving away from each other, you're going to get a rift valley that's going to happen in the center, because this is where the new lava is coming up. And so you're going to get new crust forming at what is often known as a spreading center, because it is spreading apart. And like I said, you're going to get that rift valley occurring at this location. All right, in a convergent boundary, this is where you're going to see two plates coming together. In a continental, you will see them come together and form mountains. In an oceanic continental, you're going to see the plates subduct under each other. Well, one of them is going to subduct. In that case, it's going to be the oceanic. And then in oceanic to oceanic, you're going to get subduction again, but this time it's going to be the older one that's going to subduct because it is denser. Now, subduction is where you're going to also get a ridge occurring right here. And the last that we spoke about is a transform boundary. And this is when they're going to be sliding past each other. Nothing is created and nothing is destroyed. Last up for discussion is the theory of continental drift, introduced by Mr. Alfred Wegener. Now, originally he was thought to be crazy, with good reason. They didn't know much back then, and it wasn't until many years later when we were able to take studies from samples of the oceanic floor that we noticed that at a ridge, remember this is where a divergent plate boundary happens, where we have our lava coming up and we have our divergent plate happening. It is actually the youngest, so this is the youngest floor is here at this edge, and it is all the way out here where we have the subduction occurring that we find the oldest type of crust. We also found in the study of the seafloor rock that magnetic reversal is recorded. So every so many years, the magnetic poles in Earth switch to where the magnetic pole is either the North Pole or the South Pole, and they switch back and forth, which causes the iron filings in the rock to change direction, which shows us that over time the magnetic rock is switching directions, which is showing us older and younger, which again supports the theory of continental drift. All right, as long as you have covered everything in this podcast and you understand everything that has been covered, then you should be ready for the test.